Hey everyone, we are headed into graphing trig functions next, but before we do that, I just want to talk about what a periodic function is, okay? So a periodic function is a function that has a pattern that repeats at regular intervals. So what does that mean? So here to the left is a periodic graph. Over here to the right is a non-periodic graph. If we look here, this function is just constantly like repeating, right? Over here though, if I look at this piece, it's not the same as this piece over here, or this piece isn't the same as this piece over here, okay? So think of it as it's got to look like a repetition, okay? So there's three things we're going to talk about that you need to find of these periodic functions, and that's the period, amplitude, and the midline. Period is the horizontal distance required for the graph of a periodic function to complete one repetition or one cycle. Okay? The amplitude is half the difference between the minimum and maximum values of the range. Okay, remember your range, those are like your y values, right? The formula for amplitude is the max minus the min, all divided by 2. And amplitude is never negative, so you're taking the absolute value of that, okay? And then midline. Midline is a horizontal axis that is used as the reference line about which the graph of a periodic function oscillates. That just means like it's going like up and down. This is like oscillating, okay? All right. Midline will be an equation that will be in y equals the value, okay? Like I said, it's a horizontal axis, so it's gonna be a line that goes left to right. And the equation will be y equals. All right, so let's apply this here. So looking down at this graph right here, notice that this box, oh, here, let me move that, shows one repetition. So if I box off this piece, okay, if I pick up my box and move it directly next to it, so this point matches this point, when I move it to the right, I get the same exact function, okay? Or if I take this and move it to the left, this piece is the same as this piece, all right, and so forth. So this is a periodic function, okay? So this box shows one repetition. All right, so let's find the period, the amplitude, if I can spell it, and I want to find the midline. So the period here is the horizontal distance, right? So it starts at 0 and then it ends at 2. So the period is 2. Okay, it's the horizontal distance of your box. Think of it like that, okay? The amplitude, remember, it's the max, which the top of my box is 6, minus the min, so that's 2. That's the bottom of my box, okay? I'm finding the absolute value of that and dividing it by 2. 6 minus 2 is 4, and the absolute value of 4 is 4. When I divide that by 2, I get 2. So my amplitude is 2. And that's like, if you noticed, the amplitude, it's this distance from the max to that midline or from the midline to the min. Okay, that's 2 units, and here we have 2 units. Speaking of which, the midline, it's what breaks, or it's the horizontal distance that's used as the reference line of which the graph of the periodic function oscillates. So it just basically breaks your graph in half. Okay, so it's the same on top and the bottom. So this is at the y value of 1, 2, 3, 4. So the midline is y equals 4. Okay, and that's what we're working on today. So let's do another example. If the graph of the function given below is periodic, draw a rectangle around exactly one repetition of the graph of the function. Determine the period, amplitude, and the equation of its midline. So first, I'm going to determine if this function is periodic or not. Looking at it, it looks like it repeats itself very nicely, okay? And it says to draw a rectangle around exactly one repetition. I'm going to go from here, that's the bottom, this is the top, right? And I'm going to stop, let's see, I want to stop right here at this min, so I want to go from the min to a min, or you could go from a max to a max, all right? I'm going to use this as my box, because if I pick up my box and move it directly next to it, this is the same as this part, right? Or if I take this and move it over here, this is the same as that part. So I'm good to go. But notice you could have drawn your box right here, okay? So the period of this, that distance, I start at -4 and I go to 4. So this is 1, 2, 3, 4, 5, 6, 7, 8 units, okay? So don't tell me that it's 4 units, all right? I started at -4 and I went all the way to 4. That was a total of 8 units. Now if your box was from 0 to 8, 8 minus 0 is 8 units, so you'd still get the same thing. The amplitude, so our max is 2. Minus our min is -4. Always use parentheses when you're plugging in your numbers, right? So 2 minus -4 is 6. Absolute value of 6 is just 6. Divided by 2 is 3. So my amplitude is 3. My midline is the line that splits this right in half. Okay, so I have a total of 1, 2, 3, 4, 5. Wait. I'm sorry. Midline, this is cutting the graph like right in half, right? So let's see, if my amplitude is 3, I can count down 3, 1, 2, 3. And then if I go from the minimum and go up, 1, 2, 3. So the amplitude is the same distance, remember, like how I said before, from the max to the midline or from the midline to the min. So that's kind of a way that you guys can figure that out, is take your amplitude and count down from the max or up from the min. So that is at y equals -1.
There will be something for everyone.
All right.
Remember, to bring your money and support the business students of
Okay.
in our vendor marketplace as true entrepreneurs.
Sorry about that, guys. Announcements came on, and I thought it would be hard to talk over it. But now we are on the back side of your notes and where I want you guys to try these, all right? So decide if each graph shows a periodic function. If it does, give its period, amplitude, and the equation of its midline. If it does not, explain why not. So looking at this, it looks like this repeats, right? So this is a periodic function. I'm going to draw the box because it is a periodic function, and I'm going to go from this max to this max. Okay? So there's my box. This was a periodic function, yes. So the period, let's see, I started at 0 and my x value 1, 2, 3. That's the length of my box. My amplitude is, let's see here, my max is 6 minus my min is -2. 6 minus -2 is 8. And that is positive already. Whoops, sorry. 8 divided by 2 is 4. I got a little ahead of myself there. Okay? Alrighty. Then the midline, let's see. If my amplitude is 4, from the max, I'm going to count down 4. 1, 2, 3, 4. Let's see if that's the same distance from the minimum. 1, 2, 3, 4. Yep, it is. So there's my midline. And that is at the y value of 1, 2. All right? It's as simple as that, guys. Number 2, is this a periodic function? Ooh, I don't know. If I draw a box and pick it up and put it next to it, it does not look like it's going to repeat. So no. It does not repeat at regular intervals. All right, number 3. Let's look at this. This one looks like it can be, right? I can either go from this max to that max or this min to this min. I'm going to do the minimums, but there is no right or wrong way to draw your box. No matter what you do, from the max to the max or the min to the min, your box will be the same, okay? So yes, because it repeats, right? My period, let's see. If I'm at negative 10 to 0, that's going to be 10 units. Plus 1, 2, 3, 4, 5, 6. That means it's 16. Wow, that's a big period. My amplitude is, let's see here. The max is 2 minus, the min is negative 8. Which 2 minus negative 8, that's 10 divided by 2 is 5. Oh, sorry, guys. And then the midline, so if I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, yep, it's right there. Splits your graph like right in half, right? So that is at negative 3. Y equals negative 3, that y value. Okay? Suppose you know the min and the maximum values of a periodic function. How can you find its amplitude? So say we aren't given the graph, but I just give you the max and the min, and I say, hey, what's this amplitude? Remember, the formula is max minus min all over 2. That's what your amplitude equals. Sometimes you'll see amplitude as AMP. That's how we shorthand it, okay? Remember, you want the absolute value. It can never be negative. And then how could you use the minimum and maximum values of a periodic function to find the equation of its midline? So let's think about this. So the midline is y equals. Do you guys see that really we're just taking the maximum and the minimum together, like the distance? It's basically, the midline is basically this distance from the top to the bottom of our box divided by 2, right? And that gives us right in the middle. So you could say that it's the max plus the min divided by 2. If you want to understand, or if you want me to apply that here, the max is 2, my min is negative 8. 2 plus negative 8 is negative 6, divided by 2 is 3, which is, or negative 3. That's why that was y equals negative 3. So you can use that if you want for the midline, if you want that formula, or you can just take your amplitude and count down from the max and up from the min. Up to you. Alrighty, guys, go ahead and start the homework.